Yeah. So today I gonna discuss responsible AI in the generative AI era. So we're gonna talk about those considerations of responsible AI, especially when we are using generative AI technology, as well as how we can put those theories into practice. Of course, the discussions or the examples here that I gonna talk about is related to our AWS services. So generative AI brings promising new innovation, but at the same time, it's gonna bring us some considerations in like how we can use it responsibly. It is forecasted that generative AI will drive almost like 7 trillion increase in global GDP over the next 10 years. And at the same time, it's gonna raise new risks and challenges. So especially nowadays, generative AI, they are transforming like every aspect of our business. And so in this case, we must all use it responsibly. I guess everyone knows this concept, like what is generative AI, but I still gonna briefly touch it. So generative AI, it's still an AI technology, but it can produce new original content, which is close enough to human-generated content for real-world use cases. And the model powering the generative AI, they are known as foundation models, right? So one type of foundation models that have been used a lot is called the large language models. They have been applied a lot in like chatbot, text summarization, content search, or intelligent document processing, and so on. So let's just take this large language model as an example. Like all other machine learning models, large language models, they also make predictions, right? They predict the next token in a sequence. So, and then they continuously produce like a reasonable continuation of the text based upon the training data, based upon the previous prediction. So these models, they are trained on massive amount of data with billions of parameters and via a self-supervised training process. So different from those traditional machine learning models, that one model specifically trained on a specific data set and can only apply to one focused use case. These pre-trained foundation models, they can be adapted for a wide range of use cases. So this characteristic makes foundation models broad and open-ended, which brings new risks and challenges to use it responsibly. And those new risks and challenges brought in by this characteristic, the open-ended characteristic of the generative AI models is, first, it's about veracity. A common example is hallucination, which means that the model, they generate a content which is grammatically correct or makes sense, but actually if you look into the content, you will find it's actually fault. It doesn't meet the ground truth or the reality. And the second is about the toxicity and safety. Like these models, they may generate some like toxic content, or the certain content is not safe to a certain user group. And these models, they may, the content they generated, they may also impact your intellectual property, right? And also they may disclose some of the data privacy. So these are the new challenges specifically brought in by generative AI models. And if we put all these challenges into the previously those responsible AI challenges in traditional AI, traditional machine learning, then we get a full set of considerations that we need to consider when use generative AI. So this set of responsible AI considerations includes controllability, which means that in the system, we should have some like mechanism to monitor the system's behavior, privacy, and security. So we need to kind of appropriate obtaining using and protecting the data, no matter if it's a data for model training or if it's a data in the model inference stage. And we also have to prevent the harmful system output as well as the misuse of the system. Fairness and explainability is always there, even in the traditional machine learning field. So fairness means that we need to consider the impacts to all different groups. And the explainability means that we should understand and evaluate the system's output. Like we need to know like why the system gives us this type of response. Robustness means that when we give that machine AI system unexpected input, it still can give us correct system outputs or expected system outputs. And the transparency means that we should let the user or even let the stakeholders know the development process of the system, as well as give them informed choices, like how they can use the system, like what type of use case does the system fits. Governance means that we need to incorporate those best practices into the AI supply chain, including those providers and the deployers. Since among all these considerations, the most important one is, or we always say, the first priority one, it's the privacy and the security. So let's get started from privacy and the security. One common misconception is that when we maintain the security controls in an environment, then it ensures that the privacy requirements are also met. But this approach, we commonly call it as privacy as security approach. But as I mentioned, this is a misconception. It means that actually the privacy and the security, they are not equal. They are related, but they are distinct. So security is necessary, but not the only requirement for privacy. So security, it's more related to if there's any unauthorized access, changes, and a lack of availability of the data. While privacy relates more about if there's any unauthorized collection, use, and the disclosure of information. AWS has this legislative agnostic privacy framework. Sometimes we call it LAPS. So here on this side, on this privacy framework, the left side is the privacy principles. So it consists of those core principles that drive the control set development, privacy risk management, and also the privacy governance across the people, process, and technology. So across the whole MLOps process. And it is a holistic approach to privacy regardless of the legislation. We can break down the principles into two categories. One's organizational and the other's engineering. Those principles in green colors, they are related to engineering, and the principles in white color, it's related to organizational. And these privacy principles, they are the guidelines aligning to the controls that are reflected in privacy engineering. And move on to the right side. Right side is we call it control set. So the control set represents a layered approach to privacy controls. And on AWS, currently we have like over 200 control sets that across the directive, preventative, detective, and responsive. Now let's take a look at these principles as well as how we can apply the security and the privacy controls with regard to these principles. So first, the security side. Just to simply give you some security control examples related to data minimization, data-centric design, disclosure control, continuous supervision. So on the data minimization side, what we can do is like we can encrypt the data, right, to restrict the user access. So only users with the KMS keys, they can access the data. So encrypt the data to achieve data minimization. For the data-centric design, we can apply the service control policies to do a data-centric design of the system. And for the disclosure control, it's about we can apply the federated role access to control the disclosure. And the continuous supervision, it can be achieved by a centralized logging system. Now it seems that we've covered the security part. We give some examples about how we can apply security with regard to those principles. Then what about the privacy here? Here on this legislative agnostic privacy framework, we have another set of privacy control examples with regard corresponding to each of these principles. So we can apply PI masking or PI redaction to minimize to do the data minimization, right? For data-centric design, we restrict the geolocation of the application of the system, and we can use Amazon IAM Access Analyzer to achieve the disclosure control. For the continuous supervision, it's more about the PI object access logging, and we can also use the immutable consent ledger and the data catalog to achieve the last one, individual autonomy. So everything that you expect from an AWS service, it's secure and private. So security is always our highest priority. So just like our S3 EC2 RDS, these type of classic services, AWS AI service also have the enterprise grade features to help you make your data secure. So since I'm talking about the generative AI, so let's just take the generative AI service, Amazon Bedrock, as an example here. See how Bedrock achieves the security and privacy. If you are not familiar with Amazon Bedrock, I just give you a brief introduction of Amazon Bedrock, what it is. So Amazon Bedrock basically provides you the easiest way to build and scale generative AI applications with the choice of foundation models. You can access to a set of foundation models by a single API call. With Amazon Bedrock's comprehensive capabilities, you can easily experiment with those top foundation models. The foundation models are from the first-party model provider as Amazon title models, as well as third-party model providers. You also can customize this foundation model with your own data, using the techniques such as fine-tuning or continuous pre-training. And you also can set up the augmented retrieval augmented generation approach and create managed agents. So since it is a managed service, you don't have to manage any infrastructure here, and you can securely integrate and deploy generative AI capabilities into your applications using some other AWS service that you are already familiar with. Now let's take a look at the data privacy and the security part set provided by Amazon Bedrock. With regard to data privacy, you are always in control of your data, which means that your data is not used to improve our first-party model or shared with any third-party model providers. And your data, including your prompts, model response, or your fine-tuned models, are isolated and only accessible by you. On the data security side, it's the same thing. You are always in control of your data. So your data is always encrypted in transit and at rest. And you can also use AWS IAM to manage the inference access, allow deny access for a specific model. And you can use AWS Cloud Trial to monitor all API activity and troubleshoot issues. Furthermore, those fine-tuned models, which means the customized models, they are encrypted and stored using the custom AWS KMS keys. Move on to another consideration, veracity. As I mentioned, the common example here is hallucinations. So on this slide, I put an example about like tell me some papers written by Michael Kearns, this type of prompt sending to a large language model. And we can see here the response here, it reads fluently and it seems right. But if you actually search Michael Kearns, our Amazon scholar, also a professor at UPenn, his publications, so you're gonna see the response generated by the large language models are actually not right. So the publication title as well as those co-authors are actually not the paper and the co-authors that Michael Kearns published or worked with. So to control the hallucination, the choice model is very important. All large language models, all foundation models, they more or less have some hallucination issues, right? So we should evaluate different foundation models on our data, on our use case, before we choose a model and put it into the system. So, of course, you can use a lot of tools or even third-party tools or other cloud vendor tools to evaluate the model. But since I'm talking about our generative AI service on Bedrock, so I'm gonna point out the model evaluations, this capability on Amazon Bedrock. So on Amazon Bedrock, you can use the model evaluation capability to evaluate a range of foundation models. So you can do it automatically. We allow the automatic evaluations as well as you can loop in the human evaluator to help you evaluate. So for automatic model evaluation, we have those automatic or predefined matrices for you to evaluate the model. But let's say about the hallucination, on my data, I have a specific metric or I have specific criteria to evaluate the model to see if it generates hallucination or if the hallucination that it produces is still within my acceptable range. So in this type of scenario, you can loop in the human evaluator to define, to evaluate the model performance based upon your customized metrics. After you select model, of course, you can further use your data to fine-tune the model to make it to control the hallucination. But another commonly applied approach that a lot of customers are using is by retrieval augmented generation, which means that you use your document, you use your data to set up a knowledge base. So when your end user send a prompt to the model, the relevant information gonna be retrieved from the knowledge base to improve the prompt and makes the large language model to generate more accurate and relevant answers to control the hallucination. And of course, when you set up the system, you can also specify that the model only generates answer related to your document, related to your data. If none of the information is found from your knowledge base, then just put in the prompt engineering or put on the system, like just let the model say, I don't know, these type of things to control the hallucination. But again, hallucination itself, it can't be eliminated 100%, but we can use different ways to control it. To build the RAG approach, again, on Amazon Bedrock, we have knowledge bases for Amazon Bedrock that automates the end-to-end RAG flow. So it's a native support for you to build a RAG solution. So this knowledge base, it automatically does the data ingestion, retrieval, and the prompt augmentation. So eliminating the need for you to write the custom code to build this retrieval augmented generation solution. But again, you can use all other third-party tools, or you can use other cloud vendors to build this type of solution to control the hallucination. Move on to the toxicity and the safety, these considerations in responsible AI consideration, all those pillars. Toxicity here, it is explained as a foundation model output that's, let's say, hateful or threatening or insulting or demeaning to a group of users. And the foundation model is generally considered safe when the output excludes those information that could negatively impact the individual or user group. To avoid the toxicity and ensure the safety of the content that generative AI produces, a simple way is to put consistent safeguards. So the safeguards, we can put it across the system on the foundation models. And the guardrails for Amazon Bedrock enables you to implement those safeguards tailored to your application requirements, and as well as your responsible AI policies. It can be used across the foundation models and the agents, so you can bring a consistent level of protection across all your generative AI development activities. So when you put on the safeguards, or if you are using the guardrails for Amazon Bedrock, first you can specify like what topic to avoid. Then the service, Amazon Bedrock, the service itself gonna automatically detect and prevents user queries and foundation model responses that fall in those restricted categories. So just a simple example. So a bank, they could configure their online virtual assistants to refrain from, let's say, providing investment suggestions to its users, right? And also another thing that you can do is you can set up your application with those configurable thresholds for toxicity and offensive language, using the guardrails to filter out these harmful content. So for example, let's say a healthcare provider, they can make sure its online assistant doesn't use those hate speech or insult or violate language to its users. In the guardrails for Amazon Bedrock, it also has the capability to redact the PII information. Then let's say in after customer service call, those PII could be automatically removed from the call summary. Another consideration that I mentioned before is about transparency, right? Transparency means that we should let the user or the stakeholder know like the development process of the system and how we use the user information to develop the model, and how the end user can use the system, can use the functionality of the model. So on AWS, we provide AWS AI service cards. Again, service cards here, it's not a specific service, but it's documents that tells the users about the intended use case, as well as fairness considerations of our AWS AI services. So it also documents the comprehensive development process, like how we develop the model, how we develop the service. The service cards, we have service cards for our first party generative AI model, large language model, Amazon Titan text model. And also we have the service cards for some other AI services, including like comprehend, recognition, text tracks, as well as the transcribe. So as long as these services, if they have any features related to use personal information like PII or use of your face, or ID document, then we have a corresponding service card telling you how we develop the service and how you can use the service to certain use cases. We know the machine learning development includes like multiple stages, right? From the business problem definition to formulate that into a machine learning problem. Then we need to do data collection, data preparation, cleaning. Then we select certain models to do model development, train the model, test the model, and then if the model meets our business goal or performance metrics, then we put the model into the production and continuously monitor model. So this is a machine learning operation flow, basically. In it has multiple stages. Then maybe you're gonna think like this. Okay, in the machine learning development lifecycle, like where should I consider responsible AI? Like which stage I should consider responsible AI? If it's in the data acquisition, or if it's in the model development, or if it's after the model deployment. But the answer is we should consider responsible AI everywhere in this stage. So first, starting from the business problem definition. So first we need to consider like if the business use case gonna hurt any certain user group, if gonna offend or any of your private data. And then in data acquisition, we should let the data and annotators know like how we should avoid those PI information in data collection, how we should make sure the data collected actually reflects different categories of the use cases or of the user from different user groups to make it a fairness. And let's say with regard to controllability, so we in the system, we also have we should set up mechanism to monitor and steer AI system behavior. Even after the models in deployment, we should continuously monitor the model performance to make sure the model or the system is in control. And also, when we develop the model, we should test with different scenarios to make sure, like, even if it's the model gets an unexpected input, it still can deal with that unexpected input to give us a reasonable system output. So this is more about the robustness. And on the governance side of this end-to-end life cycle, we should always control the user access, right? Only certain groups can access to the data, to the model at certain development stage. And when we deploy the model in production, we also need to control the end user access. And we have to incorporate the best practice into the AI supply chain. So including the provider as well as our downstream, those deploys. Now, with regard to the end-to-end development, machine learning development lifecycle, so there are some best practices that we provide to build the generative AI responsibly. The first, starting with the use case definition, we always recommend you to be more specific and narrow. So the more specific and narrow, the better. So don't start with a very broad use case, please be detailed. When you define the use case, when you formulate the business use case into a machine learning problem. And also, the second best practice is about the education your workforce. So you should educate, let's say you should educate the data annotators, like how to deal with those PI information, how to deal with the sensitive data, how to collect the data to achieve the fairness. And you should also educate your model developers, like how to develop the model in a responsible way, how to let the model to achieve those unexpected inputs, like how to design the system. And the third best practice is about the match process to risk with a performance evaluation. So it's more about in the evaluation side, we should assess the we should assess the risk because each use case has its own unique set of risks. And the next is more about the testing, test, and test. Each use case, they should have its own performance evaluation, and we should define specific metrics to test over the different use cases, especially when generative AI models, one model, it can be applied to multiple, a large category of use cases. So for each use case, we should specify different performance matrices to test the different scenarios. And then next, best practice is about distinguish application performance by the data set. It's also related to the open-ended characteristic of the large language model or the foundation models, right? We should gather different data sets with regard to different application and to test it to define the performance matrices. Last one, share responsibility upstream and downstream. It's more about the transparency pillar of the responsible AI. We should tell both the upstream, let's say model providers, as well as the downstream, let's say the model users, to know like how we develop the system, know the transparency and share the responsibility to make sure they use it in a responsible way. I don't know if you have heard about this. So last year, the White House met with those leading AI companies to identify those commitments related to the safe and responsible development of future generative AI models. That these models are supposed to be more powerful than any of those currently available models. So as this engagement, Amazon welcomes a new set of voluntary commitments. So we will follow these commitments to develop our services and applications and lead the community to use the technology responsibly and securely. So lastly, I want to share some like resources on building AI responsibly. So here there are 3 QR codes. Basically, the first QR code is about Amazon Scholar, his thoughts on emerging challenges and solutions in the generative AI era. And the second is about the new responsible AI innovation announced at last year's AWS reInvent. And the third QR code, it's about how you can get started with generative AI on AWS. I know I haven't covered all those considerations in my presentation. So lastly, I want to share the last piece of the considerations that I didn't mention here. It's about the fairness and bias. Our AWS Machine Learning University, we have a course, a public available course on YouTube, dive you deep into the fairness and bias. So it's a 9-hour lecture with hands-on experience, telling you like how the fairness and bias can be evaluated using tools on AWS. So you just simply scan the QR code and you can have the access to this free public course on YouTube. Lastly, thanks everyone for your time. And I'm happy to take any questions if there are any.
So during these 2 weeks, we talked a lot about information about the conflict. So is there any mechanism to capture these 2 issues? Is there any AWS service the second question is the hallucination is something that makes in a way in hallucination will actually sacrifice the creativity.
So if I hear you correctly, the first question is more about like how we can measure the toxicity.
And hallucination.
And hallucination, okay. I'd say toxicity and hallucination, these two are based upon the use case. Like there's no certain standards like these. It's not like accuracy. We can simply set up a threshold, right? Like 90% or 80%. So toxicity and the hallucinations, these two are more related to the use case. So different use case, you may define different standards about the toxicity and the hallucination. So with regard to the toxicity, it's more like, let's say, like how much more like your desired level of the content that can be safe, right? Let's say back to the guardrails on Amazon Bedrock. So that feature, it actually allows you to set your levels of control of the toxicity, that one. So you can control, put it very high, like even those small words, like you can say this is a toxic word, or you can set it very low to let all those words pass. So it's more about your level of set. There's no like a golden standard. Let's say this is the requirement of the toxicity across all the applications on all data sets. And with regard to the hallucination, again, hallucination, as I mentioned, the hallucination, it can be eliminated 100%. So no matter like what model you use, like what system you build, hallucination is more or less there. It's more about how you can leverage your data in the system or leverage your data to improve the model, to control the hallucination, or to kind of reduce the hallucination. So hallucination itself, again, there's no certain metrics to measure the hallucination, but you can define your own criteria. You can loop in the human evaluator to see if the hallucination generated model is acceptable by your use case, by your business goal.
Thank you. So it sounds like that these two are pretty relatively new content. There's no measurement yet. And well, it's a little bit difficult for the user to evaluate is that, well, after we implement those services, is that really improve the current state?
Right, there's no kind of a golden standard across all use cases. Let's say the hallucination generated by text summarization is different from the hallucination generated by a question answering, right? These two are different things. So to measure the hallucination here, text summarization and question answering, so your criteria must be different.
Thanks.
This is not like theoretically related something like that. I was curious, the vector store vector database you use, is that a new service or are you using existing database service in
You do you mean the knowledge base for this one, right? Actually knowledge base for Bedrock is native support for RAG. So it's not just a vector database, it has support for vector databases. So in the knowledge base, we have support for the vector database from our like first party vector databases like OpenSearch Serverless, Aurora, as well as some like third party data vector databases like Redis Enterprise, MongoDB, and so on.
So knowledge base is a service.
It's a feature.
Oh, okay.
Yeah, it's a feature inside Bedrock. Yeah.
Inside. Okay.
Yeah.
And then inside that there's it's both like MongoDB and now so.
Yeah, it supports couple of vector databases. And it handles the data ingestion, like it's a fully managed, so it handles the data ingestion, data retrieval. Yeah, as long as you select the vector database that you want when you set up the knowledge base.
How do customers usually deal with
Sorry, could you repeat?
How do customers ensure that the data they feed comes through us isn't exported?
Your database, I can't hear your question clearly. Sorry about that.
How to guarantee that data sent to model isn't exported
Oh.
for other uses?
Okay, got it. So, you mean like, when you send the data to the model or use a query to the model, how to make sure that's not exposed to others? Yeah, so basically you can set up a VPC, a virtual private cloud, and you kind of connect your data inside your VPC to the service via the VPC endpoint. So this is a secure way that when you send the data to the model for the inference.
Another question, you want to address the really question about use toxicity, hallucination. So I just share my observation before this customer, like Sharon mentioned, that toxicity is variable in our business. There's no business, right? So a lot of problems. For example, if you use a large language model for something like this, the large model is a very low high tolerance on toxicity emotion. That's one part to moderate it. But I think there's a customer thinking about you know tolerance, you do the tolerance sanity. So that's an example of toxicity. Now for the other case, one feedback we heard from customer in the industry is for GenAI, especially companies generating that it's no longer a battery piece like design so, which is a challenge for a lot of people to not to go for. And so the customers to have to do the benefit stuff. And then we want people to still want to do the so metrics and division to measure this general model, really not to see this channel is
Okay, all right. I think we're at a small end of our this session, and we will have a coffee break. So let's come back at 11. We will have a talk from Google Cloud and
Thanks.